Alright, in this lesson we're going to take a look at phase changes. And to start with, we need to review from the previous lesson in which we talked about solids and liquids and gases. And what we had said is that a solid is going to have molecules or particles that are super close together. In fact, they're going to have a definite shape and a definite volume because they're so close together in this fixed position where they're ultimately just vibrating back and forth. And so a liquid, on the other hand, is going to have molecules that are slightly farther apart, still close together, but now they're able to move freely from one another, which is allowing for the molecules to not have a definite shape, but they do have a definite volume. And so whatever we pour the liquid into, it's going to take the shape of that container. And the liquids, on the other hand, or the gases, on the other hand, are going to be much farther apart. And these are going to be taking no definite shape and no definite volume. They're going to take the shape of whatever they're in, but they're going to continue to expand until they fill that entire container. So no definite shape and no definite volume for gases. And so in terms of our lesson today, we're going to look at what we call phase changes. And so, by the way, these ones here are called states of matter. Okay, so these are the three states of matter. There is another one called plasma, but we're not going to talk about that one today. So, phase changes. Phase changes are going to be reversible changes in states of matter. Okay, so these are going to be reversible changes in a state of matter. So we could be going from a solid to a liquid, or a liquid to a gas, and so on. So these are what we call phase changes. And in order for phase changes to occur, we need to look at two specific parts. The first one is going to be called temperature. Okay, and we have talked about how temperature is the average motion of the particles. And so temperature, when we watch a phase change from either a solid to a liquid or a liquid to a gas, is that there's not going to be any temperature change. So the temperature of a substance does not change. During a phase change. So when going from a solid to a liquid or a liquid to a gas, a lot of us would think that the temperature would either go up or go down, but actually it doesn't. It stays the same, and so temperature stays the same. However, the one thing that does happen is energy changes. Okay, so energy is going to change during our phases. And so earlier this year we had talked about something that's called endothermic energy. And we also talked about something that is called exothermic energy. And so we said that this one is absorbing energy or taking it in, and this one here is giving it off. So it's giving off energy or giving off heat. And so these are the two different types of energies that we see. And so all phase changes are either going to be an endothermic or an exothermic reaction. And so energy is either absorbed or released during a phase change. So let's look at the specific types of phase changes. There are 5 of them that we're going to look at. The first one is going to be called melting. And so melting is going to be where we are going to have enough energy for a solid to go to a liquid. Okay, so it's going to gain enough energy. So these molecules that were once in a fixed position, you're going to have some sort of energy that is going to allow these to separate out from one another. And so if we switch the color to make that look a little bit better, you can see that it's going to split apart these molecules, and what's going to happen is that they are going to create some space between there. And so now what we see is it's going from a solid state to a liquid state. Okay, so we say that the thermal energy has been gained, and the particles are moving much faster now compared to what they originally were. So the first phase change is going to be melting. The second type of phase change that we're going to be dealing with is called freezing. And freezing is when you take away some of the energy, so take away energy to go from a liquid to a solid. Okay, so we have just the inverse of what happened before. So if we had molecules that were slightly farther apart, now what they're going to do is they're going to move back to a fixed position, and so we're going from a liquid to that gas state. And so we can think of an experiment that we take ice, and inside our beaker here, that would be the ice that's all grouped together, and we put it onto the hot plate, and while it was in the hot plate, we saw that the ice went and became just regular water. Okay, so it went from being ice down to water. And so what we saw is melting of the ice. And we see that from winter to spring when we're looking outside. In terms of freezing, what we're seeing is that you have a liquid. So imagine taking a liquid, here's our liquid, and we'll use water for example, and putting it into the freezer, and when we come back out we see that this water that was once able to move and pour out is now in a solid state, and since it's in a solid state we saw an example of a phase change going from a liquid to a solid. And so freezing and melting are two types of liquids and solids working together. Another type of phase change is going to be vaporization. Okay, so vaporization. And in this phase change, we're going from a liquid to a gas. Okay, a liquid to a gas. And so if you remember our particles, and if this is our liquid and the molecules are apart, able to move freely, and we're going to put them into a situation where they're going to be able to spread out much farther apart, so again going from that liquid to that gas phase in which the molecules have no definite shape and no definite volume, we have to have enough energy again to go from this liquid state to the gas state. And so if you think about water that gets heated up, so imagine that I have a beaker that is filled with water, and again we heat that water up. What we're going to notice is that there's going to be a little bit of steam that's starting to come off of the top of the water. And so this stuff right up here is what we would call the vaporization or the water vapor. And so that is the change of phase in which we see that a gas is produced. And so the gas is produced by heating up the water, getting the molecules to spread far enough apart that we're able to actually be able to see them or collect them. So vaporization, going from a liquid to a gas. The fourth one we're going to talk about is going to be called condensation. All right, so condensation. Condensation. And condensation is where you are taking and going from a vapor or a gas and you are moving to a liquid. Okay, so we're moving from a gas to a liquid. So what does that look like in terms of particles? The particles in a gas are super far apart, and if we are able to cool them off, so we need to be able to cool them off, and the molecules come back to a closer to fixed position in which they are going to be more fixed, creating this liquid again. And so an example that we see is that sometimes in the summer it's really warm outside and there's a lot of humidity or water that's in the air. And so during the course of the day you don't notice it, so we'll put that in blue. And so you see that you don't see that there's water molecules that is in the air, you just know that it's humid outside. But if you get a night where it begins to cool down, what happens is that all of these molecules that were once in the air begin to fall closer to the ground, and so it actually collects on the grass. And so we start to see this dew that's formed on the grass in the morning. So on the grass we see dew. And that is a change going from a gas, which is the water vapor that's in the air, going to the liquid state, which is the water that's on the grass in the morning. So again, you have two different types of phase changes, which we see a liquid going to a gas and a gas going to a liquid. Finally, the last one that we talk about is called sublimation. And sublimation is one change where you're going from a gas to a solid. Okay, so you're going from a gas to a solid, or we could say a solid to a gas. And so in this case, what we do is there's so much energy that's going to be built up in this phase change that it's going to be able to go from a solid to a gas or vapor without changing to a liquid. So that means that if the particles are in a fixed position and we are able to generate enough energy, it's actually going to skip over that step. Normally we would see it go to a liquid change and then to a gas change, which we had just gone through. We see that they ignore that step and it goes directly to the gas change. So this is going to mean that there is a huge gain in energy from this solid stage out to the gas stage. And so sublimation is our final one. And so there's a kind of a nice little way that you can picture this if you want, in terms of kind of drawing it to see it. So if I put up here gas, and over here I put solid, and over here I put liquid, what we know is that between a solid and a liquid, we know that melting can occur, and we also know that I can send it back the opposite way by saying that there is going to be freezing that's going to occur. And between a gas and a liquid, we know that there is going to be two different changes. There's going to be vaporization, and we also know that there is going to be condensation. And the vaporization is where it's going from the liquid state to the gas state, and then condensation is going down there from the gas back to the liquid state. And then finally, the sublimation is dealing with the gas, and so we say sublimation is this one right here. And what these are the phase changes. Okay, so these are the different phase changes. Finally, the last thing I just want to quickly do is I want to kind of give you a little chart to be able to remember all of this by. And so if we know that there is going to be some different changes of state, so we're going melting, and we are going with freezing, and we are going with vaporization, and we are going with condensation, and if we go with sublimation, all right, what we're saying is the fact that in terms of thermal energy, so remember all the particle movement, and also the movement of the particles, what we want to do quickly is just give us kind of a flow chart here. So if melting is occurring, so remember that this is going from a solid to a liquid, we are gaining thermal energy, so it's increasing. So that should help you out to determine if it's a endothermic or exothermic. And then we also see that there is an increase in the particle movement, right? So if we have that, we're talking about melting. So for freezing, when we're talking about that, we're going from a liquid to a solid. So what's going to happen is we're going to lose energy. So again, between endothermic and exothermic, you can determine which one that is. And then the movement is going to decrease in terms of the way that the particles are going to move. The next one, for vaporization, vaporization going from the liquid to the gas state, it's going to require energy, and so again it's going to gain energy. And what are the particles going to do? They are going to increase. And when we're talking about condensation, what we're saying is that it is going to lose, so going from a gas to a liquid, it is going to lose energy. And if it's losing energy, it is going to decrease in terms of the motion of the particles. Sublimation, going from the solid to the gas, it is going to gain energy. And so again, we would see an increase in the molecule movement. Alright, so hopefully you're able to determine between this, when any time that you gain thermal energy, it seems as though we increase the movement. When we lose thermal energy, we're going to see a decrease in the particle movement. So that's phase changes. Hope it helps.